Hello, Coach Holmes here, and today we're going to be talking about identifying three-dimensional figures. And what I mean by that is not only what the type of three-dimensional figures are, but also the different characteristics of describing three-dimensional figures. Alright, so the biggest thing we got to keep in mind is, of course, we got to know our vocabulary. Polyhedron is basically a solid figure, just a solid figure, that is bounded by, polygons. So for example, this right here, this is a polyhedron. We got a couple of rectangles, and the bases are basically hexagons. Of course, rectangle and hexagons are polygons, so since they're all being combined together to make a three-dimensional figure, that's a polyhedron, okay? Now, another characteristic is faces, okay? The faces are the polygons that form the 3D figure. Okay? So for example, each polygon like this is a face. So that's face. This is a face. That's another face. A third face. Even the bases are face. All right, so each polygon is a face. All right, so that's how we actually describe the sides of a three-dimensional figure. We call those faces. Now, an edge is the segment formed by the intersection of two faces. All right. Edge is a segment formed by the intersection of two faces. So if I look right here, each face, so I see these two faces right here, it's going to form this edge. Okay. So here we go. With these two faces I got my fingers on, they form an edge right here. Okay, that's what we call an edge. There's two faces where they intersect and makes a segment. And that segment is the edge. Next, we have a vertex. A vertex is a point where three or more, let me rewrite. There we go. Three or more edges meet. So if I look right here, here's edge 1, 2, and 3. I'm going to put my finger on the three edges. The three edges that I have my fingers on, they form a vertex right here. Okay, so that's my vertex. It's basically just another way of saying a corner. Just like a corner, just like a vertex of an angle, it's just a corner. Like it's basically, like I said, it's just a corner. So even if I make it a three-dimensional figure, it's still a corner. Okay, that's just another way of describing it. Now, there are five different types of three-dimensional figures. This one I showed you is one example. This is called a prism. A prism is going to have two bases. Okay, that's the biggest key. A prism is going to have two bases. Now this next one right here, almost lost it. This right here, notice how it only has one regular base, okay? And it has a tip, it has a vertex at the top. This is called a pyramid. And yes, it's the same type of word for the pyramids of Egypt. Okay? So if it has one base, it's a pyramid. Now this right here is called, where the two bases are circles, they're called cylinders. A cylinder is basically just like a can. If you take like a can of tomato juice or whatever, or maybe not tomato juice, but like a can of corn, that's a cylinder. It's in the can of corn is contained in a cylinder. Now this right here, after a little mishap, let me put this in real quick. This right here, this is called a cone, okay? Just like an ice cream cone, all right? It has one circular base, okay? And that one circular base makes it a cone. So the difference between a cylinder and a cone is that a cylinder will have two circular bases. A cone is going to have one circular base. Now, what about this one right here? That looks like a ball. Okay? What looks like a ball is called a spear. All right? It's a spear. It's just, like I said, it's just like a ball. Whether it's a baseball, tennis ball, basketball, whatever, it's a spear. All right? Now, there are different things that describes or characteristics of each figure. So first, I want to zoom in a little bit more. So first, let's look at this prism, for example. Okay? I want to look at this prism. So this right here where the arrow is pointing at, that's covering this, that is called a base. Okay? Wherever it sits on, whether it sits on the top or the bottom, that's called a base. However it sits on, where the two bases are the same figure like this, across from each other, that's called a base. Now, this right here, we could call that, well, I can make it a different color, just so that we distinguish the difference. That right there, we could call it a face. It is a face, but it's a lateral face. And what I mean by that is that it goes up and down, okay? Because lateral means up or down. Next, we're looking at this line right here, this edge. It is an edge, but it has a particular edge. It's a particular name called a lateral edge. Okay? Now, another way of describing it would be height. That's how you normally describe that lateral edge. You basically call it a height because of how tall it sits or how tall it stands. All right? Now, next we're going to look at a cylinder. So again, looking at this right here, this part shaded, this is a base because again, where however it sits on, it's the same shape as each other. So it's a base. Next, this right here, while it's not a particularly an edge, you can describe it as an edge, but mathematically speaking, it's probably not so much of an edge, but really it's more of a height. All right. Next, we have this little segment right here. Now notice that it's from the center of the base goes to the edge of the cylinder. What do we call that? Well, we call it a radius. Okay? Now, it may not look like a circle from this perspective, But if I were to take this cylinder and just kind of turn it like this, get it on its side, and I look directly at the base, it would be a circle. It's just three-dimensionally drawing it makes it difficult to see that it's a circle. But it is a circle, no doubt. Next, we're going to talk about pyramids. Okay, now pyramids have more distinct features than prisms or even cylinders does. So for example, this little point right here, that's a vertex. Okay, now there's plenty of other vertex around, like these points. Those are vertex. But what makes it different is that instead of a base up here, it has a vertex. Now next, this is covering the face right here. So again, we still call this a lateral face. Okay? We still call it a lateral face. Now I just want to erase this part real quick, because the next thing this arrow is pointing at, and I'm going to use a different color, is this line right here, where it's from the vertex to the base. Okay, that's the big key. From the vertex to the base, it's called a height. Okay, that's just basically how tall it stands. Okay, that's what a height is, how tall it stands. Now, if I go a little bit further, let's make it blue. Looking at this part right here, see how it's kind of more slanted? That's a word we use because it's called a slant height. It's called slant height. Instead of basically how tall it is, instead of basically how tall it is, it's basically a more of a height for the face of that pyramid. All right? So it's more of a height of that pyramid, or more height of that face rather than the pyramid itself. That's the big difference. So if I'm going from the vertex to the base, that's my height. But if I'm going along the face, that's my slanted height. And then in the very bottom, which is this area right here, that's just my base. Okay, that's just a regular base of the pyramid. Okay, now, so again, this little point right here on the cone shouldn't be any different. This point is the vertex. Okay, now, while typically it doesn't have so much edges, like it doesn't have like a distinct edge, it's pretty much an edge all the way around, making that little point. Okay, next we have this right here, which makes it a slant height, because again, it doesn't show me how tall it is, but how long this edge is. Okay, from the point to the edge of the base gives me the slant height, and the same idea applies for the pyramid, from the vertex to the edge of the base. Next, I have this right here, which that gives me my height. Now, here's another thing that makes the cone different from the pyramid. We have to distinguish this radius here. So a cone does have a radius, a pyramid won't. So that's one thing we got to remember with cones, is that we got to distinguish the radius of the cone. And then we have this part right here, which we call it the base. All right. So So really, one big significant difference, while this does have a lateral face, this is not so much of a like the curve leading up to the vertex. It's not so much of a face, but we can find the slanted height from it. Okay, and while this does have a slanted height, one big significant difference is that a pyramid is not going to have a radius, but a cone will. A cone will have a radius, and that's one thing to keep in mind. Next is a spear. And there's two things that we really have to worry about with spears. Just two qualities, two characteristics that we have to worry about. For one, we have to worry about this little line right here, which is a radius. So we do need to know the radius of a spear. But this line right here that the arrow is pointing at, that I'm circling it in green, that green line is called a great circle. Okay? It's called a great circle. And what is a great circle exactly? Well, it's if you were to draw a circle on a spear, the largest circle is the great circle. So like I could draw a circle from here to here, but it wouldn't be the largest part of the spear. So the largest part of the spear is the great circle, okay? And we don't have to worry too much mathematically speaking about it, but it's nice to know that whatever the radius is, if we were to draw a radius around the spear, that would give us the great circle. So the biggest thing in this lesson is just knowing these characteristics. Let me fix this real quick. It's just knowing these characteristics. The biggest thing is just recognizing like the base, the lateral face, the edge or the height of it, and just knowing the radius and knowing our slant height. Because next time we're going to be talking, because in this unit really, we're going to be talking about finding area, surface area, as well as volume. And we have to be able to recognize what each of these features are. Okay? And that's what this lesson is all about. The math we'll get to later, but we got to be able to recognize each of these characteristics. Thank you and have a good day.